In the high Sonoran Desert outside Tucson, Arizona, scientists from Lamont Doherty Earth Observatory, Woods Hole Oceanographic Institution, NASA's Goddard Space Flight Center, and the National Oceanic and Atmospheric Administration converged at Columbia University's Biosphere 2 laboratory to conduct an ocean rain experiment. Specifically, a freshwater rain over Biosphere 2's ocean ecosystem. Funding for this experiment was provided in part by a grant from the David and Lucille Packard Foundation. For nearly 2 hours on the morning of March 18th, scientists conducted their experiment on rain-induced air-water gas exchange, as some 6 inches of rain fell on them and into the ocean. Principal investigator Dr. David Ho of Columbia's Lamont Doherty Earth Observatory says that understanding the flow of gases across the ocean surface is a key component to predicting and assessing the future evolution of climate.
Gas exchange is an important process globally in terms of the exchange of carbon dioxide between the atmosphere and the ocean. And the main mechanism affecting gas exchange globally is wind, but then there could be these secondary mechanisms such as rain. And this process has never really been studied.
Oceans serve as an important sink of carbon dioxide generated by the burning of fossil fuels.
Once photosynthesis converts the CO2 into organic matter, it then sinks to the bottom of the ocean, and carbon dioxide is sequestered at depths and doesn't return to the atmosphere for 1,000 years.
The rate of gas exchange between the ocean and the atmosphere is controlled by conditions such as turbulence and bubbles in the surface layer.
The quantity we're trying to measure is turbulence at the air-water interface. We have a suite of instrumentation, acoustic Doppler velocimeters, and we're coupling that with measurements from infrared imagery, which actually measures processes right at the interface.
In freshwater environments, raindrops falling on the water surface increase the rate of air-water gas exchange. In saltwater environments, the same effects have been observed, but there is an additional complication: the potential layers or stratification caused by the addition of freshwater on top of saltwater.
Measuring the salinity profile helps us understand how the freshwater is moving down into the ocean.
To do this experiment in the real world would be really difficult.
Biosphere 2 Ocean is uniquely suited for controlled experiments, as researchers can determine the amount of rainfall, the size of the raindrops, and the wave state of the water's surface.
This facility is ideal compared to other facilities that exist out there because we have the very high ceiling here, which allows realistic rain to be generated. And then we have a wave generator, which makes waves just like the real ocean.
Yesterday, in 2 hours, we had approximately 6 inches of rain, that the drops were fairly close to a natural rain event.
During this experiment, some scientists studied how accurately the Biosphere 2 Ocean and its rainfall mimic natural systems.
We wanted to see how closely the raindrops mimic nature.
The facility also allows scientists to test new scientific instruments and techniques.
We've collected samples from Biosphere Ocean in the past, so I came out here to collect more samples while someone else was measuring the gas exchange so that I could go back and further refine our technique for measuring ocean productivity.
To fully understand the effect this rain is having on the gas exchange of the Biosphere 2 Ocean, the research team used several methods of recording data.
The name of my instrument was Skin Deep, which is an acronym for Skin Depth Experimental Profiler. Skin depth is a layer at the surface of the ocean where molecular processes dominate over turbulence. It's this thin, very thin, millimeter thin layer that controls mass and heat across the RC interface. So the design behind my instrument was to try and measure the temperature of this layer directly.
The ultimate goal is to improve the understanding of the processes that influence air-water gas exchange in the presence of rain and waves in saltwater systems.